This is the last video for the topic on angle pairs. And we are going to talk about the last pair of angles as for lesson 2 is concerned because we might encounter more pairs later on. But as of the lesson 2 is concerned, the last angle pair is the vertical angles. Vertical angles are angles that are directly opposite one another when two or three lines intersect. And we do have a theorem which actually tells us about the relationship of their measurements. According to the vertical angle theorem, the vertical angles are congruent. Congruent means their measurements are the same. So if we are going to take into consideration that angles L and S are vertical angles, we are going to apply from numbers 1 to 3 that measurement of angle L and the measurement of angle S are equal to one another. When you say equal, looking at number 1, we could say the measurement of angle L is equal to the measurement of angle S. This is unlike complementary, supplementary, or linear angles forming a linear pair, wherein we could sum them up and equal to 90 or 180. Here in vertical angles, really, they are just equal to one another. So in this case, measurement of angle L is equal to measurement of angle S. And we just simply need to substitute the value. So the measurement of angle L is 58 degrees. This would be the value of the measurement of angle S. And by symmetric property, we can simply interchange both sides without altering the signs nor the values. The measurement of angle S is equal to 58 degrees. How do we check? Checking for this is just simply trying to make sure if they are really equal. Checking for number one is very easy because we don't have any variables to consider. So the measurement of angle L must be equal to the measurement of angle S. Measurement of angle L is given to be 58 degrees in the given, and the computed value for the measurement of angle S is also 58 degrees. They are equal. That would mean this value for the measurement of angle S being 58 degrees is correct. Again, we're talking about vertical angles now, and they must have the same measurement. Let's look at number 2. In number 2, we do have a variable here, but then again, they are considered to be vertical angles, so we can equate their measurements. That would mean the measurement of angle L is just equal to the measurement of angle S. Before we could solve for the measurement of angle S, we do have here the variable. So let's try to solve for it by first substituting the given values. The measurement of angle L is 105 degrees. It must be equal to the measurement of angle S, which is x plus 4 degrees. To solve for this, let's subtract both sides by 4 degrees as well. So the measure we have here 101 degrees is equal to x. And by symmetric property, x is equal to 101 degrees. Let's try to substitute it to the measurement of angle S to determine its measurement. The measurement of angle S is equal to x plus 4 degrees. Equate them. We have 101 degrees for the value of x plus 4 degrees. You have 105 degrees. You may do checking or simply just by observing the values for the measurement of angle L and the measurement of angle S. Since they are equal, this means this is satisfied, and that would mean that the value for x is correct. No need for two too confusing checking here, simply look at the given the values or the computed values for both of them. And if they are equal, that would mean your solution is correct because that is what the vertical angle theorem is telling us, that the vertical angles are congruent or they have the same measurement. For number three, still, we could say that the measurement of angle L is equal to the measurement of angle S, since we already have the claim earlier that they are actually vertical angles. So equate them. That's 2x minus 61 degrees must be equal to x plus 23 degrees. And then solve for x. Why? Because before you could solve the measurement of angle L or or nor or the measurement of angle S, we do have the variables here. Solve for x first. To do that, we will have here 2x minus 61, and let us add 61. The other side will become x plus 23 degrees. Sorry, I forgot the degrees. Very important. Let's make it red. Plus 61 degrees. Okay, so we will have here 2x. This becomes 0 already. Is equal to x plus 23 plus 61 is 84 degrees. Okay. Now that we have this value, we can now subtract both sides by x. We'll have here 2x and we have minus x is equal to x plus 84 degrees minus x. We subtract x both sides so that this would be taken out from this side. X minus x becomes 0. 2x minus x becomes x. And that is equal to 84 degrees. Now that we have this value, let's try to substitute this for measurement of angle L and measurement of angle S to solve for them and see later on if they are really equal or not. If they will be equal, this is correct. If they are not equal, we need to re-examine this process here. So let's start with the measurement of angle L, which is 2x minus 61 degrees. 2, x is 84 degrees minus 61 degrees. 2 times 84 is 168 degrees minus 61 degrees. So the measurement of angle L is equal to 107 degrees. Let's look at the measurement of angle S. The measurement of angle S is equal to x plus 23 degrees. And x is 84 degrees plus the constant 20 degrees per given. So we have 84 plus 23 is also 107 degrees. This is the measurement of angle S. No need to have too confusing checking. Look at just simply the values for the measurement of angle L and the measurement of angle S. Both of them measures 107 degrees. That would mean the value for x computed earlier to be 84 degrees is the correct value, which could make or support that the measurement that angle L and angle S are vertical angles. So I would like to, before we end this video, I would like to remind, if I talk about vertical angles, they are just congruent or they have the same measurement. So simply equate them and solve for the unknown if there are unknowns. Okay, so you may try to review this video. This is the last video for lesson number 2. And we will have more videos soon, lesson number 3 and the next unit. So watch out for those videos. See you soon. Goodbye.